So hi everyone, welcome to programming problem solving through programming in C tutorial session. This is the last session that will be having for this semester by me. So this is in this session I will cover few the left topics, and then we will have some revision on the topics that are covered for this semester. If you have any doubts, you can ask during the session. So we'll start in a few minutes when everyone joins. So, hi everyone. Is my screen visible and am I audible? Can you just confirm? You can just type in the chat box if my screen is visible and I am audible. Great. So this is a final session that I will be taking for this semester for the course problem solving through programming in C. So I would start by taking a quick recap of the topics that we covered in the previous session, and then we can proceed further. So on this Friday, we saw a few problems on structures, and so we solved a few problems on data structure in C. How if you want to store a variable containing data from different data types, then you can use the struct data structure provided by the C programming language. So these were the few questions that we covered during this session. So if you have any doubt, you can type in the chat box and I will explain the question again. So first question, which of the following are the collection of different data types? So we already know structure is being used for this. And then when you pass a structure variable, it is passed by value. So copy of the structure variable is passed. Then we saw some programming questions. And then, yeah, we saw then the next topic that we covered was pointers. So we saw how to use pointers, how to declare pointers, how to use pointers to pass references to variables. So if you have any doubt in using pointers, then you can ask in the chat box. So we saw some pointer arithmetic operations. We saw how to do some pointer arithmetic. So for example, let's say in this question, we had to answer a few things related to this. So what it is actually printing. So let me like reiterate about structures and pointers, and then we can proceed. Structure. Structure is so is the text visible? Whatever I'm typing. So that allows storing different document as in a single variable. And storing data of different data types into a single variable. So that's why we use struct. The syntax is like this. So we use the keyword, use keyword struct to define a structure. So the syntax is like this. So let's type in the syntax. Struct, let's say variable struct data, and we use the opening and closing parenthesis followed by variable name, and within the parenthesis we can define the different data objects that it can store. Let's say I want to store a name, and then char name. Then let's say this is a structure that stores data of a student in a school. So we have their name, their roll number, and let's say grades, marks, right? So this is how the structured data type looks like. So there are different ways to define the structured data types. So we essentially don't need this variable name here. So we can create a struct data structure like this, or we can create the same data structure without giving a name to the data structure. So we don't need this data here, and we can use simply define the variable names here, student1 and student2 and so on. So these are different ways in which you can define a struct. You can see there is a difference between these two declarations. Here we gave a name data, and in the second case we did not have a name to this struct, and we essentially used it to declare two variables, student1, student2, at the time of declaration itself. So the benefit of the first approach is that you can now use create any other variable using the name data, and then let's say student1 anywhere in the program. Whereas if you use the second approach here, you can't create any other variable inside the code. because you are not giving a name, so you are only stuck with these two variables. Fine. So yeah, there are different conventions of defining struct. So yeah, this is how struct works. So some of you might have heard about linked lists. So do you know what is linked list? Are you taught about this? I don't think so, but if yes, then I can give a beautiful example. So you can type in the chat box. Yeah. So basically, linked lists are a set of connected nodes that store data. So and you can use structures to define those linked lists. So essentially, uh, it contains pointers that links different data blocks, so different structures, and these pointers are used to traverse through the list. So I think you can like go. I don't think that is that much important for the scope of this course because in the lectures I did not see any mention of such lists, so you can ignore them. But yeah, structures are really very powerful data types in C. You can use them to create linked lists. There are various applications of single linked lists. They make multiple operations very fast. So yeah, this is where structures are used. So if you have any doubt regarding structures, how to use them, then you can type in the chat box. So yeah, so one of the students is asking, can you give an example of type def and structures? So yeah, so every one of you is familiar with type def operator, type def keyword. So we are talking about keyword type def. So and everyone knows is to define a data type name. Give a name to a data type. So every one of you is familiar with data types. If not, you can. So if you are familiar, just leave it. If you are not, then type in the chat box. I'll wait for a few minutes. So essentially, it gives and used to give a name to a data type. So let's say, let me give you. I believe no one is typing in the chat box, so every one of you is familiar with the concept of type def. So maybe we can use an code example to understand this. This is it. Text is visual, everyone. So yeah, what is type def? Where we can use type def? Let's say we want to create. We don't want to use the name int to declare integer data types. Then we can use the keyword type def. So you can use type def, and you can define the alias for that data type. So let's say I want to define int to I. So then what means if you say I x equals to 10, this is equivalent to int I equals to 10. So you can simply see that it works. The value variable is, and I'm using percentage d access specifier here, and then I can type in the value of x, and you will see that program will compile correctly and give us the results. The compilation is successful. The value of the variable is 10. So you can see this is equivalent to saying I'm talking about INTI. So this is useful in the programs where the variable names are really large. Let's say we are declaring long data structures. So if we don't use type def, then what we would need to do, we need to type in long x equals to this, and then you have to type LD, I believe. Okay. So LLD is the format specifier. So everyone please note that I'm using the format specifier LLD to specify a long integer. Then when we run the code, you can see the value of the variable is 10. So long is essentially used to store very large integer values. So now let's say I have to use long keyword in many times in a code, then it will be very time consuming. Then a shortcut would be just define a new data type LL. So that refers to the long data type. Then instead of typing long, you can use LL, and you can see this will work. The value of the variable is 10. So everyone, can you see this? So can you see what is the usage of type def? Basically, type def is used to give a name to the existing data types in C. So is this clear? Great. So now what we'll talk about, we will see how to use type def with struct. So let's write a code for that. Hashtag include stdio dot h and then void main. Now let's say I define a struct variable, which is a global variable. So it is accessible by any function in the code. So yeah, okay. So let's say we have a struct data, and it contains the roll number, char, name, and then float marks. Fine. This is a data structure. And let's say I don't want to everyone now, if I want to create a data struct object here, I need to type in struct data student one. Then again, if I want to create another data student, I have to type struct data student two and then assign the values. But there is a shortcut. Let's say I don't want to type this long every time I need this to create an object of this data type. What I can use type def here. So I can type def struct data as, let's say, D. Fine. Now, instead of doing this, I can simply create D student 1, D student 2. So now you can see I don't need to type in the entire string struct data here. I just need to type in D. That is the name for this data type struct data. So now let's say I want to assign few values also. So that's really simple. So let's take a user input and do this. So and let's create some temporary variables. So int temp roll number, float temp marks. So these are the variables that we are using to take in the user input, so that they will be used to assign the values to these objects. So let's say cal temp name. Fine. Now we can give a prompt to the user. Kindly enter the details of the first student, and then I have to type in, I have to ask for a name. So name, and then I can use scanf percentage. So name is a string, and I want to take in string from the yeah, name. So let's. I would also like to check if the input is correct. So let's see if my method way of taking input is correct or not. So gcc struct.c. So this is correct. Yeah. So for taking input string, you need to use the format square percentage as, and we are not passing the ampersand here because we know whenever we declare arrays, the array name itself is the pointer to the first, or it's a pointer that contains the address of the first block, memory block in the array. Fine. So now let's ask for the another details. So let's change the line and then ask for roll number and use the scanf keyword here. The comma temp roll, and then lastly we need the grades of the student. Fine. So I can use scanf here, and this is percentage f and temp marks. Finally, what I need to do, what we need to do, we simply need to assign the values to the variables of the object. So student1 dot roll equals to temp roll, and then I can use string functions to copy the name into the desired place. So hashtag, for that we need to use the string.h library. So I have included it, hashtag include string.h. Now we can use the strcpy function to copy the data into the student1 data type. So student1 dot name, and I have to type in Tim name here. So let's see if the entered data is correct. So we would like to print the details of this data type. So what I can do, I can create a new function that prints all the entries in the given struct. So void print data. The input is t data. Let's say we are using a function prototyping here. So function body is not defined here. We can define the function body anywhere later in the code. So let's say after the main function, I am defining the data. So let's type in the student details are as follows, and then to print the data. Name is percentage as, line change, then roll number is percentage d, line change, and then marks is percentage have. So percentage have, these are the access specifiers that I'm using. And let's type in the values dot roll data dot name and then data dot marks. Finally, what we need to do, we simply need to call this function to check if the details have been stored correctly. So print data and pass in the variable student1. So let's see if our code works. GCC struct.c. Acha, I just did a mistake. There is, the order was incorrect. Now it should be correct. Hmm. Okay, so yeah, I missed the ampersand operators in the scanf here because we need to pass in the pointer, the address at which we have to store the input. So let's clear this and compile our code and then run it. So let's say my name is Rupesh, my roll number is 1 and I scored 60 out of 100. So I think there is some mistake. Hmm. Achha, I haven't set the last value. Student 1 marks equals to 10 marks. So my name is Rupesh, my roll number is 1 and I have scored 60. So you can see the details are correct here. So this is how you can use struct. This is what struct data structure looks like. You can use this to store variables or different data types into a single variable. To reduce the uh, to shorten the declaration every time, you may use the type def operator. So you can use the type def like this. So anyone, do you have any doubts, Shreya? Are you able to understand this? Fine. So anyone, do you have any doubts in using struct and other data structures? So this is how structs looks like. How do we use type def there? So I will I'll wait for a few minutes, let's say 2 minutes, and then if you have any doubts in using structs and this example, then I can explain this again. Okay, so let's move on to the other things, other stuff during this session. So this is how we use structs to store data of different data types. So now let's talk about pointers in C. So in the previous session, we discussed few problems on pointers in C. So anyone, do you have any doubt? So were you able to understand all these problems? So we did some pointer arithmetic and then so anyone, do you have any doubts in using pointers? So I had also given you some practice problems. So let's say I want to solve a problem. First, I should reiterate what are pointers, and then we will proceed. further. So let's talk about pointers. What are pointers? Pointers are data structures just that store the address of data in C. So pointers are used to, it's a data type, not a data structure, that store the address of a data in C. So let's see this through an example. Oh, that's great. So let's say I have declared a variable int x. Then how the data is, how the variable is stored, and let's say I give a value of 10 to it. Then how the value is stored in the memory. So let's say this is the memory, computer memory. Fine. And it's divided into different blocks of different sizes. And let's say integer takes some amount of size for us, let's say 4 bytes. And now what we need to do, we need to store the value of this variable x. So for what that value stored at a particular memory location in the main memory. And let's say this is the main memory, and then in that case, x, the value of x is stored at this memory location. So 10 is stored here in the main memory. And let's say the memory location is 1000. Fine. Now, if let's say I declare a pointer variable. So asterisk is used to declare a pointer variable. So int asterisk y, and I define it as the address of the variable x. So this is actually ampersand. This is the result of operator ampersand over the variable x. So I hope every one of you is familiar with this stuff right now, by now. So we have been using this ampersand operator since the beginning, where we are using the scanf operation function. So let's say I create a pointer variable asterisk y and assign it the address of x. So basically what y contains, y itself contains, let's say y is the pointer y stored at some memory location. So let's say this is a like memory, and let's say y is stored here at a memory location 2000. Fine. So y, actually what y contains? Y contains 1000. So this is what a pointer looks like. This is how it works. So essentially a pointer is used to store the address of other variables in C. So we use the asterisk operator to declare or operate, use asterisk to declare a pointer. So let's say int x equals to 10 and I want the address of x, then I have to declare int asterisk y equals to ampersand. So I have a question here. So let's say I'm writing this int y equals to ampersand x, and I'm saying y pointers store the memory location of other variables in C. So that is integer. So y essentially all the pointers store some integer value. Fine. So why do we need this int to be specified here? Why do we need int to be specified to define a pointer here? So let's say I was creating a character variable, character c equals to a. And now if I want to create a pointer for this, what should I write? I should write int asterisk, let's say z equals to an ampersandage a. Is this correct? Ampersand c. Can you just tell me if this is correct? And if not, then why? What is the mistake here? So I hope every one of you have gone through the lectures on pointer. So I believe every one of you know the reason behind why do we need to specify the data type of the pointer also. Where, where in case actually it only contains the address of the variables and the address is an integer value. So why do we need to specify this data type here every time we declare a pointer variable? Anyone? So you can type in the chat box here on. So am I audible? Is my screen visible? I can't see any answer from you guys, so it's a bit confusing. Am I audible? I think there is some technical issues. So hello, hello. Am I audible? Can anyone just type in the chat box and confirm? Right. So yeah, can you tell the difference, spot the mistake in this code? So let's say, is the text visible? So let's say I'm value which is stored in the address, stored in the pointer. So I don't get it what you are saying. So yeah, pointer variables are used to store the address of other variables in C. So what I'm asking is this declaration correct? So I'm declaring a variable C that is of data type character, and then I'm declaring a pointer Z that contains the address of C. And what I am saying is, why is this declaration correct? Why if I use int asterisk Z to declare the pointer for a character data type, is this correct? No, fine. So good. So Shreya, can you answer why is incorrect? And what? Just don't tell me why it's incorrect. Just tell me what is the answer. What should be the declaration of the pointers that here? Huh. So this is your answer is correct. So we need to specify the data type of which the address is being stored in the pointer. This is because whenever we do pointer arithmetic, let's say I type in z equals to z plus 1. Then what happens? It and let's say C was stored at a memory location. Um, let's say C was stored at a memory location 1000 and character occupies 4 bytes. Then z plus 1 would correspond to 1 would correspond to memory location 1004, not 1001. So this is the utility of defining the data type. So this is also known as some scaling factor, like associated with every pointer. So whenever you do pointer arithmetic, the values are incremented or decremented depends upon the data type of the pointer. So that's why this is important. And why do we need this? Because let's say we have a character array like this, char C, char C and some A, let's say H E L L backslash. So let's say we have a character array like this. C corresponds to the address of the first data block of the array, and C plus 1 corresponds to address of the second element in the array, and that is the address of C with the address of H plus 4. So that's why this specification of the data type is important. And this is how character arithmetic works. Fine. So yeah, this was how we declare pointers. Then let's say we have a PTR, and it points to some location, and I want to be let's say we want to get the data stored at that location. So can anyone just tell me how to do this? So we have a pointer start PTR that points to some location, and we want to get the data at that location. So you can type in the chat box. So let's say this is the memory. And I have a pointer that points to this memory location, and I want the data stored here. I want the value 10 here. Then which keyword is to be used? Which token has to be used? Which operator has to be used here? Anyone? You can type in the chat box. So let's take an example. Let's say I'm writing a function to swap two variables, void swap, and we already did this problem. So let me do this again. A and then p, and what I am doing, I want to swap this values. How I will do this? So you can see we are not returning any values from this function, and I want to I want the value to be reflected in the main function. So let's say this is the main function. And I have declared a function variable int a comma b, and let's say a equals to 10, b equals to 20, and I call swap here, and the address of a and then address of b. So can anyone tell me how to fill this function? How I can get the values stored at this memory location? So let's say I have a pointer variable. I want to get the value stored at the location pointed by that variable. So you can use the dereference operator asterisk a. So asterisk a means value stored location a. So then what you do? Temp, you use the naive approach. Just use the store the values. So temp contains the values stored at the memory location a, and then you update the value at that location with the value stored at the memory location B, and then you give the value here, and you will see that our code works. So everyone, do you understand the concept of this dereference operator in pointers? So for pointers essentially point to a memory location in the main memory, and you want to get the value stored that at memory location, then you have to use this dereference operator, that is again the asterisk operator. Everyone of you, are you familiar with this? So no one is answering my question. So am I audible? Is my voice clear? Like, let's say I'm audible, but is my voice clear? So say my voice is not clear or I am not audible. I mean, okay. Now is the voice clear? Shreya, can you confirm if my voice is clear? Okay. Are you able to understand what I'm speaking? Like, it's very much. If it's really difficult, then I need to make some changes. If it's fine, then I can proceed. So should I proceed? So are you able to understand whatever I'm speaking? Fine. So what I was talking about here is I was asking about, let's say we have created a pointer variable like this. So it points to a memory location. Let's say we have a pointer variable this, and it points to a memory location here in the main memory. And I want to get the value stored at that location. So can you tell me how to do that? So let's say we have an integer pointer. So int and star ptr, fine. And this pointer points to this memory location, and I want to get the value stored at this location. So can you tell me how to do this? So anyone? So this is what I was discussing right now. So for this, you can use the dereference operator, and that is again star ptr. So in the code, if you type, let's say this is an integer data type. It's the pointer is storing integer data. So let's say I am declaring a variable. I want to get the value. So int value is equals to. So you use the dereferencing asterisk operator and then type the pointer name. So in this way, you can get the value stored at that pointer location, at the location stored defined by the pointer. So for example, I was trying to write a function swap that takes in addresses of two variables and swap the values present at those two variables. So you can see we have two integer pointers, int a and int b as an arguments. Then what I do, I create a temporary variable that stores the value, temporary values for use for swapping. Then I assign the value stored at the memory location denoted by a to the variable temp. Then what so for this, I actually use this asterisk, which acts as a dereference operator here. So every one of you now you get what is dereferencing. And then the code is pretty much standard. I dereference the value stored at A, assign the value stored at B, then update the value stored at the memory location B. So every one of you, are you able to understand what I'm saying here? Are you able to get it? What do I mean by dereferencing here? Dereferencing a pointer. So no one is typing in the chat box. Fine. So thank you. Let's proceed further. So this is what all about pointers and pointer dereferencing pointers, and then pointers arithmetic, like that we saw with this example only. So yeah, whenever you do +1, so it jumps to the next memory location, and let's say it occupies 4 bytes, then it jumps by 4. So pointer arithmetic we saw, then we solved a few problems on pointer arithmetic. Fine. So let's see a few topics from the last session only. So this were some few problems that we did on pointer arithmetic. So we saw how pointer arithmetic actually works. So any one of you, do you have any doubt in this question? So if you don't, then we can proceed further. So we have a character array, and then we are assigning a pointer p that contains the starting address of the array, and then we do some operations. So will you able to solve this on your own by now? So great. So let's proceed further. So this was all I had on pointers. So if you want, we can solve a problem on pointers, but I believe you can do these problems by your own by now. So if you get time in the end, I will solve these problems for you guys. So let's now I'll be these were a few topics that I covered from the previous session. So there are two other topics that one more topic that I wanted to discuss regarding the syllabus that was covered in the previous class, previous tutorial. That is file handling, file input output operations in C. So let's start with that only. So yeah, file IO in C. So let me take this heading. So let's start with the file IO in C. So till now, whatever problems we did were like this. So let's say till now, whatever we were doing for storing data, what we did, we have a let's say main memory. So every one of you is familiar with the memory organization of a computer. So there is this main memory. This is main memory. And then there is a disk. That's just secondary storage. That is slower, and data transfers occurs between these two. So this is a secondary storage. Fine. So this is so this is how the memory. So there are other faster memories here also, like caches and cache and registers, but they are not of that much importance for us right now. So right now in all the programs, whenever I hope every one of you understand this concept of main memory and secondary memories, and all the data that you create during the program is stored managed by the main memory. So because it's faster, And if the data is not present, it is fetched from the secondary memory and copied into the main memory. So main memory is essentially represented by your RAM. So every one of you is familiar with the idea of RAM, random access memory. So RAM is the main memory of your system, and then disk includes the hard disks. So you can, these are hard disks. So secondary memories is a HDD or SSD and hard disk drive, and then main memory is the random access memory. So basically RAM. So the benefit of main memory is that it is fast, so the computations get faster. So whatever program we have done till now, what we used to do, let's say I wanted to create a variable x. So where it was being stored, whatever variable you create, it needs a memory location where the data can be stored. So whatever operation that we did right now, the data was stored in the RAM, in the main memory. So let's say x pointed to this and the value was stored in this main memory. So the next thing that we want to discuss in this tutorial is this: how to fetch data from the hard disk drive, that is the secondary memory, into the main memory through a C program. So we'll do this right now. So let's say we have a file stored. Let me use a different color here. So it's a bit slower. Okay, it's not visible. Low will work. So let's say we have this file stored in the secondary storage, and I want to copy contents from the file into the main memory. So let's say I copy the content from the file into the main memory, and then I use this in our program. So let's say I have variable var. So let's say I have a variable var, and I want to copy the content stored in the memory in the file present in the secondary storage. I want to copy it into the main memory that is being used accessed by the variable var in our program. So how to do this file operation? So files are stored on the secondary storage, and then we can use read and write data from files. So we will do two types of operations here. So read, one is read. So and the second one is write. So let's say I write some data, and that changes are reflected onto the file. So you don't need to understand how this process actually works. The main objective of this tutorial is to understand that we can also do operations, manipulations on files stored in on the hard disk or the secondary storage of your computer. So let's see how which libraries is provide this C. So use libraries defined in stdlib.h. So for file input or output, you need to use libraries defined in stdlib by the lib.h, and the functions that we will be seeing for this session would be let me see what functions. Yeah. So here's the code. F open. F right. So yeah. So the function that you will be using is f open, f close to close, open and close a file. So open a file. Then fclose is used to close the file. Then fread is used to read data from a text file. Achha. No, fread is used to read data from a binary file. From a binary. So that binary can contain any kind of object, any data. So from integer, string, anything. So before that, we would see what is fcats. read text from a file. And then there's this fputs. Fputs is used to write data, write text data into a text file. And then fread is used to read data from a binary file, and fwrite, write data to a binary file. So these are the functions that we'll be using for doing file operations, input output operations in C. So all these functions are defined in the library std lib.h. Fine. So you can see we have two functions for reading data. One is fgets and fread. The other one is fread. The difference is this: fgets can only read ASCII characters, that is string, from a text file. So let's say if you have a txt file containing string, then you can use fgets to read data, read string from that file. If it contains some other data, non-ASCII characters also, let's say we are storing data of a struct or any integer data, then in that case, you can use fread, that is used to read data from binary files. Similarly, to write the text, you need fputs, and to write data, any arbitrary object or data object, you can use fwrite. So we'll see these applications in a while. So through few of the programs. So before that, I would like to take a break for 5 minutes. So in my desktop clock, you can see it's 13:59, 15:59. So we will resume at 16:05. Fine. So let's take a break for 5 minutes and then we'll resume. Break for 5 minutes. We'll resume at 16:05 my clock. So, hi everyone, welcome back. Let's resume. So, we were talking about file operations in C. So, yeah. So, we saw that there are few functions, library functions that are useful for doing file input output forms in C. And by file input output, what do we mean? So, basically reading text data from the secondary storage, copying it into the main memory, and then doing some manipulations. Then finally, writing the changes into the file again on the secondary memory. So the functions that we use is file. So one of the functions that I forgot to type in is file. So file is a keyword that used to create a pointer to the data stream. So basically by data stream, what we mean, we name the data file. So let's see how to use this. So let's start with basics. So opening. So file IO basics.c. So we all know we need the standard IO for input output, and then we use stdlib to use the file operations, and then we can define the main function that is required by every C program. Now, let's say we want to create a new file. So let me create a new folder where I will containing all the data. So let me call that folder as storage, and let's say we are creating a file. So the first keyword that is important is the file. So it's an keyword that is used to create a pointer that refers to a data stream. So let's say I want to call it fptr. So I will create a pointer fptr that will contain the contents of a file. That will contain the address of a content of a file. Now let's say I want to open a file. So for accessing the data in a file, you need to open it. So we will use the function fopen. So so the syntax for fopen is was it? Huh. So the syntax for fopen functions looks like this. So you have to give in the file name, and let's say the file is stored in the folder storage with some data. The file name is data.txt. The second thing is the mode in which you want to open the file. So there are different modes in which you can open the files, and this value will be this will return a pointer to that file, and that pointer is stored by this pointer fptr. Fine. Now, what are the modes that can be used? So the mode can be the modes can be read, write, append, and others. You can look on the internet for various modes for doing file operations. So let's say for us, we are trying to write some data into a file. So we will use W that denotes write operation. Now there is a possibility that it fails, the function of a open fails. Then what you can do, then it will return a null pointer. So you just need to check if fptr equals to null, then IO error has occurred. So basically error has occurred while opening the file. So what you can do, you can tell the user printf the file open operation failed. So you can give a nice exclamation here and then exiting the program. backslash n. So now you can use the exit keyword. So every one of you, I hope you are familiar with the exit keyword. So if the file of fopen function wasn't able to open the file, then our program exits, giving this warning message. Fine, error message. So yeah, fopen takes in a file name and then the mode in which we have to open a file. Right now we have used the write mode. W is for write mode, and it returns a pointer to that file that we have stored by fptr. If fopen fails, then it returns a null pointer. Fine. So everyone, all of you, are you getting this? So if you have any doubt, you can type in the chat box. Everyone, anyone? Fine. So now let's proceed with our program and see what is happening. So first, let me go into that storage folder from which we are going to read any files. So everyone, can you see so everyone of you is familiar with the ls command in Ubuntu. So it's used for listing the directories, folders, and files present in a particular folder. So currently we are in the folder storage of our program. And you can see we are trying to open up a data.txt in write mode in the folder storage. So currently through our terminal, we are in the folder storage. And we can see when we list, we see there are no files in this folder. Now what we have done, we have opened the file data.txt in write mode using fopen function. And now we will close this file. We will simply close this file. And then we will see what happens. So let's compile the code. So file IO basics, run the code. And then in the storage folder, when I list, you can see a new file is created with the name data.txt. So every one of you, are you able to get this, what I have done right now? So I created a file pointer. I opened a file name data.txt in the folder storage in the write mode. And I checked if it was able to create that file. And then I closed that file. You can see the file data.txt has been created. Initially, it was not there by our program. So the file of operation has been successful. And when I open the data.txt file, so let me see if there is magnifier settings. So just 1 minute, let me open up the magnifier so that accessibility. So follow the mouse concept. Fine. So now you can see I have opened up the data.txt file here in my editor. You can see the file is blank right now. There is nothing in this file. Fine. So essentially what we did is we simply created a file data.txt. We opened a file data.txt in write mode and we simply closed it. That's it. That is a basic file open operation here that we have done. We have not read any data from this file, neither we have written any data in this file. So let's say what I do, I delete this file. So let's go ahead and delete. We can use the keyword rm to delete any file in C in Ubuntu in Unix environment. And let's go ahead and delete this file. Now you can see there is no data.txt here. The file has been deleted. And let's see what happens if we compile and run our code. You can see the file open operation has failed, exiting the program. So what's the difference right now in this case and in the previous case? The difference is, so in earlier, in the previous case, when we use the write mode here, we were able to create the file and this error did not occur. But when we have deleted that file and we are trying to read that file, open it in the read mode, then it gives us an error that the file operation failed, exiting the program. This is because during write mode, the C compiler creates the file. But when we use the read mode, then it does not create the file. It needs the file to be present there so that the program can read in the content from that file. So that's why we are getting the error in this case and not in the previous case. So every one of you, are you able to understand this? Were you able to understand what I was trying to explain here by the different modes of opening a file? Fine. So let's go back to the right mode. And so yeah, and let's go back and create our file, and then we will proceed further. So gcc file iob6.c dot slash a dot out and move to the folder storage. And now you can see data file is here. Fine. So now what I want to do, let me create a new folder, prep, and let me move everything into that folder, and then we will start afresh. Fine. So in this program, through this program, we understood how to create a file in C. So we basically use the write mode to create a file data.txt into the folder storage using C. Mhm. So you can see there is a file data.txt. So we were able to create that file on the disk in the folder storage here. Fine. So now let's go ahead and write text to text file dot c. So now what we want to do, we want to create a text file, write some data into it. io.h and then include stdlib.h and then main. So let's go ahead and first create a file pointer, file asterisk ptr, and then create a file. So fptr is equals to fopen file name. So that would be storage front slash text.txt. Let's say, let's call out file some text, and then let's open it in write mode. Now we need to check if the file creation is successful. So if fptr is not equals to is equals to null, then error has occurred. So we simply copy this error. So this file, the file operation failed. Fine. So yeah, now at this stage we have opened our file, and then we are ready to close that file also. fptr. Fine. So now the base is ready. Now what we need to do, we need to type something into the file. So let's say we create a string char data to be written, and let's assign some value to it. Welcome to my first text file. Fine. Let's create this string data. And now we want to write this data into the string. And we all saw that there is a function that allows us to do this, is fputs. So let's go ahead and use this. So fputs, then we need to give the data that is stored in the data. And we want to write into some file stream that is generated by fptr. Fine. So let me do this one thing. First, I will not write the text. First, let's remove this line. First, let's just create that blank file, and then we will see how the data has been written. Fine. So now you can see in the storage folder, there is only one file data.txt. There is no other file. So let's go ahead and compile our program. So write text to text file.c and then run that program. Now go back to the storage folder, and you can see there are two files, text.txt. So there is a command echo that can be used to print the content of a file. So let's say I want to print the content of the file text.txt. So I don't cat is used for this. Huh. So cat is a command, cat, that can be used to print the content of file. Currently, you can see the file is blank. It does not print anything. So we can cross verify it by opening the text.txt, and you can see the file is blank right now. So now what we need to do, we need to write some text into this file. So we can use the fputs function. So we created a character string data, name data. We stored some string into that data variable. We use the fputs function to write the data into the file stream denoted by the pointer fptr. Let's go ahead and run our code and see what is going on. So gcc write, then run the program. Then again, move to storage folder. You can see there is text.txt, and then now what I have done, I have printed the content stored in the text.txt, and you can see now we can read that text present in that file. So let me clear this, and again cat text.txt. So you can see, you can welcome to my first text file. So this was a text that we have written in the text file. So you can see that it has been written in the text file. So every one of you, are you able to understand this? How I was able to create a new text file and type in the contents into that text file. So Chandran, do you have any doubt? Fine. So I hope none of you have any doubts. So the next step, what we are going to do, we are going to read that text from that file. So let's create a new C program. Read text from text file.c. So we can reuse the code, and just we need to change a few things. So we are going to read the text from that file. So we have to open it in read mode. Then now we need to read data from the file. Let's create a data, and we consider that it contains maximum length, maximum 80 characters. And for reading the text from the file, we already saw that we have a function fgets that allows us to read text from a file. So let's go ahead and use it. So fgets. So it takes in three arguments. First is the string in which we want to store the data, so variable, so that is data. Then the maximum length of that string, that is at t, and then the file pointer, that is fptr here. So now if we print the data, contents of the string data, we can see what were the contents. So the contents of the file are, so you can change the line here and then print the value and data. So let's see what happens. So read text. Oh, yeah. So by mistake, I used print function. So it's essentially printf, not print. So let's run the program. So the contents of the text file are welcome to my first text file. So you already saw in the previous program, we created a text file. So Shreya is saying if any file is stored opened in write mode, then the file pointer will never return null. So this is a really good question, but yeah, it should not return null. But there are other cases. There are cases in which it can return null, such as your disk has no space left. In that case, somehow, in any case, if your program is somehow unable to create a file onto the disk, in that case, it will return null even if we open it in write mode. So these cases arise when there is no space left on the disk, or your program has no adequate permissions to create a file on the disk. So Shreya, did you get the answer? So yeah, the null point, it should not return null in case of write mode, but there are cases in which it might return. Fine. So let's proceed. So yeah, through this example, we understood that how to create a text file, then write some content into text file. And then let's say if we have some text file and want to read contents from that file, how to do that. So this is a basic program for that. So any one of you, you have any doubt in doing file input output operations in for text files, you can type in the chat box and I will clear your doubts. So you can type in the chat box. I'll wait for a few minutes so that every one of you are familiar with this. And if you have any doubt, you can type in the chat box. So I believe none of you have, no one has any doubts. So let's proceed further. So this is all about reading, writing text files from C program. So now, so Chandran is saying if data is already present, then. So acha, you are saying that let's say we have a text file. We had the text file text.txt. It contains the data. Welcome to my first file. And you are saying, let's say if I write to this file again, then what happens? That is the question you are asking, Chandran? Yeah, so let's see what happens. So basically what happens whenever you call this function, no, it creates a new file. By creation, it means if that file is already present on the disk, it will replace that file with the new file containing the same name. So it will be the contents will be deleted and a blank file will be created. So we can do this. We can check this. So you can see text.txt is blank, contains some text right now. And let's say we use this function, we do not write anything in that file, but just open that file in the write mode. Let's see what happens. Um, so you see the text gets deleted. So I can also cat the data storage from text.txt. You can see the text is blank right now. So Chandran, were you able to understand what I was saying? Old contents will be deleted. So let's say initially it contains some data, and now if I run the program and then I see the data is gone. So yeah, it actually creates a new file with the same name and replaces the old file. Let's say if you write something else, so let's say I have re overwritten over the file. So let's say it contains welcome to the file my text to my first text file. Now let's run this code and let's see what happens. And then you cat this. You can I have re overwritten over the file. Understood? Fine. So this is the behavior when you try to open a file in the write mode that already contains some data. So this was all about text files. Now, not necessarily everything is a text file. So whenever you watch movies, you play video games, or you do some mathematical, you store some numerical values. In that case, the data is not necessarily a text data. Such files are sometimes known as data files or binary files. So binaries are used to store non-ASCII characters. Binary files are used to store such non-ASCII characters. I believe my system. So let's see how we can do that operation in C. So let's create, let's again, we start by, um, so the opening the file is same as we have opened the text file, but there is a difference in doing reading and writing in text file. Write data to a binary file dot C. So let's say we have a function, we have a program like this, std, and hashtag include std lib.h, and let's say we have a data present in our program that contains student details. So let's say struct data. It contains the student name. Sorry, char name. Let's say it contains the student name, then student roll number and student grades. And let's say I already create a helper function that prints the data. So you struct data d and print the details, and then name is given by percentage s. Change the line. Roll number is given by percentage d. Change the line. and marks is given by %f change line, and then d dot name, d dot roll, d dot marks. Fine. So this is some function that this is the function that we use for printing the data present in a struct. Now let's say you want to write this data to a file on the disk. So let's say you have entered some data into your program and you want to write this data into your disk. How would you do that? You can't no longer, this is no longer a string. You want to store structured data right now in a file. So for that case, we can use different functions. So let's try to reuse some program. So fine. Hmm. So let's say you get the data from the user and you want to write that data into a text file. Structs data student. You take in the user input and let's run this program and see if everything in the main memory is working fine. So GCC write data. Okay. So we have not included the string.h here because str copy is present in that header only. So we need that. Acha. So let's say I am typing my name, roll number is 1 and I scored 60. So you can see the program is working fine. So the variable data student contains the data of a student. Now what we want to do, we want to write this data onto a text file. So the first thing that we need to do is we create a file pointer. The second thing we need to do is we need to open that file using the function fopen in write mode. So storage /student data.txt in the write mode. So it will create a file, such a file, and then we need to check if it's the operation is successful or not. So for that we can use this, reuse the program. Now what we need to do, we need to write this data into the file. So we saw that we have a function that allows us to do this, and that is fwrite, used to write data to a binary file. And it's a binary file, so it's no more the name should be .txt, it can be data.bin. So we have to use the function fwrite now. So the arguments are, we need the pointer we need the address of the object that we are going to store of the variable. So we are going to store the variable student. We need to give the size. So for that we can use the variable keyword size of struct data, and then we need to give the file pointer. So these are the arguments for the function fwrite. So essentially it takes, and there are some issues, too few arguments. Okay, just one thing, 1 minute. Two. अच्छा, one क्या? Okay, let me check once. Acha. So it also requires one other another argument, that is the number of elements that we are going to store of this size, of the size struct data. So we are going to store only one variable, student. That's why the value is one. So let's say if it was an array, then we would have to type in the length of the array here. So this is how fwrite works. Then we have successfully written the data into the binary file. Then we can close it. fptr. Let's see. So right now we want to check if all the files, if that file is already present or not. So I can see what is present in the storage file. So you all can see there are only two files, data.txt and text.txt. So let me zoom in, and then you will be able to see. So in the folder storage, there are only two files present right now, data.txt and then text.txt. Let's go ahead and run our program and see what happens. So gcc write data to binary file.c and then run our program. And let's put in my details. So Rupesh, my roll number is 1 and I scored 60. Okay, so the file write operation failed. So let's see what's the issue here. I believe I am not allowed to create a bin file. That is the issue. Write data to binary file.c. That's a data.bin. Okay. Acha. Again, the issue was I was using the read mode here. That's why it was giving the error. So pay attention whenever you write code. So I'm using read mode here. The file is not present right now. So it gave this error. So let's retry. I have corrected the error and let's see if it works. So the name is Rupesh, roll number is 1 and the marks are 60. So you can see the program is printing my details. The student name is Rupesh, roll number is 1 and marks are 60. So let's see if the file has been created or not. So let's go to storage and see. So you can see now a new file has been created named studentdata.bin. Fine. So this is how you can create a binary file in C. So you can write non-ASCII data onto a file in the disk. So this is how you do this. So from this program, we have created that file. Obviously, we can't read that file directly. We have to use uh, some decoder for reading this file. So this can simply be done by using reading the content of this data in C. So write data to a binary file, and the next operation that we'll be seeing is read data from a binary file. So every one of you, now are you familiar with how to write data? Uh, how to write binary data into C? If yes, then we can proceed. So what is AXTN? Chandran, can you explain? You are saying yes, only AXTN. So what does this mean? Extension. Acha. Huh. So yeah, this is so you can read any binary file. You can write any binary file using this program. Fine. So now what we need to do, we need to read data from. Now we have written onto the binary file .bin. So shall I proceed? Were you able to understand how we created a new binary file and wrote some data into it? So essentially PRS. So I don't know if I get you. Acha, proceed, sir. Yeah, fine. So let's proceed further. So now we have created a binary file and we have stored a data that is not text. It's basically an object of the struct data type data containing these details. Now what we are going to do, we are going to read that file. So for reading the content of that file, we use fopen and open the file in the read mode. Then what we need to do, we can't use fwrite, we have to read it. So we will use the function. We already saw that we can use a function fread to read data from a binary file. So we will use the function fread and we will see that we get the value. So let's see what are the arguments. So it requires a pointer of the object in which you want to store the data. So let me see if I'm doing it correct. Read binary.c. Huh. So we need to pass in the address of the object in which we want to read the data. So we want to read the data into the variable student that we have created at the beginning of this program. So it belongs to the data. We are getting the same struct data here while reading the data, so that the data can be read into the same data type without any ambiguity. So we pass this address, then we need to pass the size. So we can use the size of function, and we are using struct data. Then how many elements? Only one. And then we again pass the file pointer fptr. Now what we need to do, we need to print the data value that we got. So now we can print the data and you will see the values will be correct. So is the print data defined as struct data t? Acha. So every one of you, are you able to understand? Now I'm using the fread function. So I opened the file, the binary file in the mode read mode, and I used the function fread to read the file denoted by the file pointer stream into the variable student. And now we are going to print the data present in the variable student. So let's go ahead and compile and see the output. So let's clear this and read data from binary file and read. So you can see after running our program, the student details are name is Rupesh, roll is 1, and marks are 60. So our program is able to read data from that binary file. So this is the actual data that we wrote using our program in the previous program. And now in this program, what we have done, we have read that data from this file, the written data from that file. So every one of you, were you able to understand the idea behind this reading and writing data into a binary file and also text files? So this is how we do file input output in C. So if you have any doubt, you can type in the chat box. If you don't have any doubt, then yeah, I can wait for a few questions from you guys. So it's already 4:45. So 15 minutes are left. If you have any doubts, you can type in the chat box. If you are not able to understand how I read data from the text binary file, you can type in the chat box and I will explain this process again. So Chandran, what do you mean by multiple records? So you are saying array of struct? Chandan, can you elaborate your question? You are saying we would like to know how to go for. Yes, if there is so let's do that again. So let's say we have two students and we want to do that. So I will create an array struct data student of size 2, and let's put the values. This is the details of the first student, and let's repeat this process for the second student. Of the second student. Fine. So I hope you will be able to follow this example. So I'm not doing nothing. I have simply replaced that variable student with an to an array of struct. And at the zeroth index, I am taking the content in details of first student, and first index, I am taking the content of the second student. And then what I need to do is, so yeah, so these two are ready. Now what I have to do, I have to open a file in the write mode, binary file. Then I'm passing in the fwrite function. I already told that the third argument is the number of elements of the size of this, that is struct data. So we are using an array containing 2 elements. So instead of 1, we will pass in 2, and you will see this program would work. So let's go ahead and see. So let's run this program. First student is Rupesh, roll number is 1 and marks are 60. Then the second student is, let's say, Lakshay, the roll number is 2 and the marks are 90, and the details are saved. So now what we need to do, we need to read that data. We want to make sure we have written that data into the binary file. So I'll use the code read data from a binary file. And the only difference here is I have to create the student as a character array. I mean, as a struct array. And then instead of passing 1 as the number of elements, I will pass 2 as the number of elements in the function fRead. Then what I have to do, I have to print the data. So let's print given prompt here, the details of the first student is \n, and then we have to print the data of the second student. So let's run the program. And now you can see there is some issue. Acha, haan. I had done a mistake here. Now it's correct. So now you can see I was able to write data that was stored in an array of structs, and I was able to read that data into a different array of struct from a different file. So Chandran, is this clear? So this is how you can use array of data. Fine. So this is so basically by multiple records you mean arrays. So these can be multi-dimensional arrays also. So instead of using one-dimensional array, I could have multi-dimensional array, and that this would work. Essentially, this function, writing to binary files works for any kind of object in the C programming language. So you can use this. So any one of you, if you have any doubts, you can type in the chat box. It's already 4:50, 10 minutes are left in this session. If you have any doubts, you can type. Otherwise, we can leave the session. Chandran, void pointer. So you're talking about void pointer in C. Okay, let's see what you're talking about. So let me see. Acha. Hmm. So basically, what a void pointer means is it has no associated data type with it. So let's say you say right now for pointers, what we were using. Let's say if I used to want to store an integer pointer to an integer variable, I need to use int ptr. A void pointer is declared by the keyword void star ptr, and it has no data type associated with it. Fine. So why do we need it? It is useful because it can be typecasted to any data type for and and how that can be done. Basically, malloc and calloc functions are use these voice pointers. So basically, you can return any data using void pointer of any data type, and then you can simply cast it to your required type. Let's say I want to cast it to integer. So then you can use this like this. So basically, void pointers are the pointers having no data type. So a major disadvantage is you can't dereference them. So Chandran, you are saying when nothing to return, then why void? Then it is generic. So yeah, it can be used to uh, like it can be used to return a pointer to any data type. For example, you want to return data type of return a pointer to a particular object stored in the memory location. Then void pointer can be used, and then you simply need to typecast it. Hmm. So, so you are saying when nothing to return, then why void? So basically, you want to return something, but you actually don't know. Let's say the library function doesn't know it what the memory. Let me give an example here. Hmm. So let's say you have some library function, and in that library function, you say in the main function, main memory, in the main memory, create a chunk of block that contains some data. So, and you give the size, you specify the size. Okay. And there is a function f that takes in the size and it creates this chunk of memory. Then what you need to do, you need to return the address of this side. So you can use an eraser here. So then what happens if you create a chunk of memory here, and then what you need to do, you need to pointer into the program function. So let's say I have a pointer here. So this pointer ptr points to this memory location. Now what happens in your program? This function f essentially did not know about the structure, anything about the data that is going to be stored in this particular memory location. It only knew that I need to create the memory location of a particular given size. So I have created, let's say, for 10 bytes. Let's say I have created a memory of 10 bytes here. Fine. So I gave in 10 here, 10 bytes, and the function creates a memory chunk of 10 bytes and then returns a pointer of that memory chunk. And then in this case, you will want to access this memory location to store something here, but you essentially don't know what data is to be stored here, basically by the function f. So in that case, what it will return? It will return a void pointer. So it will return a pointer that contains this memory address, let's say 1000 here, but it doesn't know what data type it is currently. Now, let's say in your program, you know that what data you are going to store here. Let's say you are storing a struct here. So you can simply typecast this pointer into a struct. So now what you need to do, you need to simply typecast to struct. So that's why these void pointers are useful. So let's say struct data, struct D. So then you can simply typecast to struct D and then use that memory location. Huh. So in the malloc function, you so what is the syntax of malloc function? In the malloc function, you don't give the data type you are passing in. So let me open up maybe a documentation from any website. Hmm. So you see, it returns a void pointer. So I hope the text is visible. It allocates size bytes of uninitialized storage. So it only takes the size as an argument. It is not taking the data, I mean data type of the that will be stored in that chunk of memory. So what it does, what the malloc function knows is that I have to create some memory chunk into the main memory and just return the pointer that will be useful while storing or accessing data of that memory. And then what you need to do, let's say you are creating creating that memory for a structure of data, then you can use it, simply typecast it to that, and then you can use that memory. So are you getting what I'm saying, Chandran? So you specify the typecast. So you specify the typecast, but malloc function doesn't know the data type. The malloc function only gets the size where you can specify the data type. That's what I'm asking. So in the malloc function, you are not passing any data type, no? So you're typecasting outside the malloc function. That's what I'm saying. So let me explain you. Let's say this is the malloc function. Okay. So this is the malloc function. You pass in some size to this function. Okay. And then you do the typecasting here. No? Am I correct? So let's say it's an integer pointer. So you use int asterisk here. So is this syntax correct? So you are doing the typecasting. I'm not disagreeing with you, but you are not passing this type inside the malloc function. So malloc doesn't know what is the data type. You know what is the data type. So malloc, what it does, it only allocates that memory chunk, then provides a void pointer that point. So it basically what it does, it takes a chunk of memory of the given size, creates a void pointer, and then that points to that memory location, and then return that void pointer here. Then what you do, you convert that void pointer into an integer pointer, or let's say you have a struct pointer, then you could have used a struct keyword here, struct and the pointer name, data name, let's say D. So this is how it works. No, malloc is not getting the data type. That's what I'm saying. Exactly. Now you're getting the point. Yeah. So only the block of memory is allocated, and then later you provide the data type and you typecast it to that. So that's why you use void pointers in C. So it's already 5. So I believe I will have to end this session. So I hope I was able to answer most of the questions that were raised by you guys. So the last session that I am taking for this course for this semester. So please feel free to backs for my sessions or by the NPTEL, by the form shared by the NPTEL team. So I can't give any tips for the exam because I myself don't know what is the format of the examination. So I have no idea of how the examination goes or what type of questions come in the examinations. But yeah, I'm sure if you practice all the questions that I have shared with you guys, then they will be able to cover most of the things. So who's saying we will face it again? So yeah, I don't know like what is the pattern for the examination. So I was here only to help you out for solving few problems using the concepts that were taught in the classes. So yeah, I'm not the right guy to ask these questions. You can ask the NPTEL team for that. Great. So let's end this session. Thank you.